we go. So welcome to the ISEB 11 Plus mock exam walkthrough. Today it will be delivered by me, Kevin, from Think Academy. Right, so let's start right now. Starting with the first question. So these are all questions with relatively low correct rates. Yeah, and if you have any questions during the walkthrough, you can save them until the end of the walkthrough. I will answer all questions at the end altogether. Right? So the first one, question number 4. Bud thinks of a number in Roman numerals. He adds, this is 6, if you know your Roman numerals, and then multiplies by 3. His result is 27. All right, so I'll write it down, everything. Give me a sec. Yeah, so this is 6, add 6, multiplies by 3, and then the result is 27. So it's actually just asking you to solve an equation. Yeah, we are all confident with solving equations. So what number did Julius think of? Write your answer in Roman numerals. I actually got a picture over here so that it can show you all the Roman numerals right here. Yeah. So you can have a look. Yeah, or you can take a screenshot, or actually you can Google it if you're not familiar. Yeah, be familiar with this before you go to the test. Right, so we can say the original number that Bud is thinking of, actually should be Julius, is x. So x plus 6 will be the new number. Yeah, he adds 6, and then the new number is multiplied by 3. And the result is 27. Okay, so we solve for this equation. X plus 6 will be 27 divided by 3, which is 9. So x plus 6 is 9, x will be 3. So 9 minus 6, x equals to 3. And remember to write your answer in Roman numerals, which is this one over here. So you just copy it down, 3i. Yeah, this is the answer. Yeah, so that's question number 4. Let's move on to question number 6. The figure is made up of a square, ABCD. Okay, the square is outlined with the blue pen. This is the square, and a right-angled triangle ADE, which is the red one, right here. The length of ED, this part, is twice the length of HC, this part. Yeah, and it is also given to us if you read the diagram. Since there are two little bars over here, that means HC is equal to DH. Yeah, so these are some basic information given to us, but actually it is more than we needed, more than necessary. We don't need that much information to solve this question, actually. We just need the 2 bars, meaning that it's bisecting. Yeah, the point H is bisecting CD. Okay, and also the last condition given to us, the area of the square ABCD is 64. That's all we needed. Okay, so I'll erase everything. So first of all, so if you remember the formula for area of square, that will be the side lengths squared. Yeah, so the side length is A, for example, A. Then the area will be A squared. Okay, and because we know the area is 64, then if we want to find A, the side length, we simply need to look for the square root of 64. So A will be square root of 64, which is 8. Okay, so that means the side length of the square, say BC, CD, DA, and AB, are all 8 meters. Okay, be careful with the unit. So if this is 8 meters, that means CD is 8. And if H is bisecting, that means this is 4 and this is 4. Okay, and that means AD is also 8. Yeah. And that gives us ED as well. This is 8. So we can find the larger shaded triangle. And remember, since this is perpendicular, so this will be our base, ED will be our base, and AD will be our height. And the formula for us to find the area of a triangle is base times height divided by 2. So it is 8 times 8 divided by 2. So this is the area. I'll write subscription for the triangle for ADE triangle, ADE. Yeah, and that will be 64 divided by 2, which is 32 meters squared. And then we want to find the smaller one, which is triangle FGH. Yeah. Actually, you can draw a horizontal line over here to help you. Yeah, it will help you determine. So if you flip the triangle on top over here, you will find that it's actually one small square. I'll use another color to mark it. It's one small red square. Yeah, it's equivalent, the area. Okay, so it's easy for us to find the area of a small square. It's just 4 squared, so it's 16. So the area of triangle FGH equals to 4 times 4, and that will be 16 meters squared. So the answer is just 32 plus 16. So the shaded area is 32 plus 16, which is 48 meters. This is one way to do it. Yeah, there's an alternative way. If you're familiar enough with your geometry, let me erase this and give you the alternative method. All right, a straight line over here. This is method 1. This is method 2. So remember that if so for the smaller triangle, you don't need to bother the larger one. For the smaller triangle, if we fix the base as FH, yeah, the base is FH, and then if you look at it, if you turn your head 90 degrees clockwise, you will see that the height for this triangle, no matter where we put the point G, yeah, the height for this triangle is always the length of BF. Yeah, it's always 4 meters. Okay, so we can put the G anywhere we like. Now, in this case, if we want to do it simply in a simpler way, we can put the G to point C. Yeah, this will be our G dashed. And we can transform our original triangle into a new triangle. I'll draw it in another color, in purple, perhaps. So this will be our new triangle. And the area is the same, yeah? No change in area. Okay, and we don't want it to be here because it's a bit far away from AED triangle. So we move it horizontally to the left, okay? Over here. The area also didn't change, yeah? We're just moving it horizontally, so translating it. So this will be our new triangle. Okay, and I'll mark the shaded area again. So the total shaded area, I'll mark it in deep purple, is this one over here. So I believe you all know how to find the area of this triangle. Yeah, DE is 8, DH we already know is 4. The height AD is also the side length of the square is also 8. So it'll be 8 plus 4 times 8 divided by 2. Okay, and that will give us 19 times 8, which is 96, divided by 2 is also 48 meters. This is the second way. Yeah, you manipulate this figure. Right, that is question number 6. Let's move on to question number 13. John spent 2/7 of his money on exercise books and 3/4 of the remainder. Okay, this is important. 3/4 of the remainder on 6 pens. The 6 pen is unnecessary information. We don't need it. The question is, what fraction of his money did he have left? Okay. So, first of all, because he spent 2/7 of his money, then that means what's left, yeah, after buying the exercise books, what's left will be 1 minus 2/7. Yeah, this is what is spent. So what's left is 5/7. Actually, we should also include a step. 5/7 multiply the original whole, which is a 1, gives us 5/7. So this is 5/7 of his money left, and which is the remainder. And he then spent 3/4. So 3/4 of the remainder on 6 pens. Right? So we should be, so what's left? You can first multiply 3/4 and then use the original, the remainder, the 5/7 to take away what you got, the product. Or you can do it simply. You can simply write 1 minus, okay, I'll write it over again. So 1 minus 3/4. This will be the fraction that's left, yeah, after buying the 6 pence, which is 1/4. And then multiply the quarter with the remainder, the 5/7. And this will be the fraction of the money left. Yeah, this is why I wrote this 5/7 multiply 1. Yeah. And this is the answer, actually, 5/28. This is the fraction of the money John has left. Okay. And that's question number 7. Let's move on to question number 15. This is an inclusion and exclusion problem. So some common mistakes are error of omission or repetition. Yeah, so that means sometimes we right, let's look at the question first. 4 strips of paper are stuck on the table as shown. Each one is a rectangle that is 12 centimeter long and 2 centimeter wide. So the 2 dimensions of the rectangles are given to us. This is 12, the length, and the width is 2. Okay, and because this is 2, this is the width of the vertical rectangle. That means for this square, the overlapping part is a square which has side length 2. Yeah, it's a 2 by 2 square. All right, so by error of omission, we mean that sometimes students take away two of the squares. Yeah, so 2 times 2 is the area of one of the square, and we count how many overlapping parts we have, and we found that so 1, 2, 3, and 4, and the students take away twice the 4, so 8. This is error of omission. That means you're taking away more than you should. Because we're looking for the area of the table covered, yeah, we still need one of them. Okay, we need to take away the one on top. Yeah, we're counting 1 extra, not 2 extra, 1 extra. We need to take away 1. Yeah, the 4 areas once, not twice, once. So instead of 8, we should be multiplying 4. Yeah, this is the area we should be taking away. And if we calculate the total area of the 4 rectangles, that will be 12 times 2. This is the area of one rectangle, multiply 4. And that will be, this is 24. 24 times 4 is 96 cm squared. But this 96 centimeter squared is including the overlapping. Yeah, if students give us 96, that will be the classic error of repetition. You're counting more than you should. Yeah, the error of omission is counting less than you should. So this gives us 2 times 2 times 4 is 16 centimeters squared. So 96 is when we are including the 4 overlapping parts. Take away the 4 overlapping parts 16 once, and that will give us the correct answer, 80 centimeters squared. Okay, and that's question number 15. Let's move on to question number 17. Yeah, again, another geometry question. So it's about angles. The two lines over here, they're horizontal lines, and the two arrows over here means that they are parallel to each other. Yeah, and if you remember from I think the summer holiday term lesson, that's 2 parallel lines with 1 intersecting line in between them, and then we will generate 2 pairs of opposite angles, and they are equal to each other. And obviously this angle A is opposite angle, which is equal with this angle 31 degrees. So that means A is 31 degrees. This is fundamental knowledge that you should remember, and not something I can derive for you. You just need to remember it. And then next is the exterior angle theorem. Yeah. So for the rectangle over here, if we look at this obtuse angle, yeah, then the exterior angle is if you extend this line. Yeah, and the flat angle, take away the obtuse angle, will give you the exterior angle, which is angle B in this case. And the exterior angle theorem states that the exterior angle of any triangle is the sum of the two other angles that are not that angle for the exterior angle. Sorry, just remember that the exterior angle is the sum of the 2 other angles. They're not neighbors of this angle. Okay, so B in this case equals to A plus 35 degrees, and we know A is 31 degrees, so it'll be 31 degrees plus 35 degrees, and simple calculation, 66 degrees. That's the answer. Okay, let's move on to question number 20. Yeah, so this one might take a big chunk of time. Let's look at question A first. What is the sum of all factors of 24? Okay, so we can try to find the fact. We can first try the prime factorization of 24. Right, so remember how to do prime factorization. We use short division using this sign. Yeah, we start with the smallest prime number we can have, which is the only even prime number, which is 2. So 24 divided by 2 is divisible, gives us 12 as quotient. 12 is still divisible by 2, so we stick with 2, and it gives us a quotient of 6. And 6 divided by 2 is 3. 3 is a prime number, so we stop there. We don't go any further. All right, so we start with 1. 1 is a factor of any number. And then we have 2, obviously. We have 3. Can we have 4? Yes, we can. 2 times 2 is 4. Can we have 5? No, we cannot, because 5 is a prime number and it's obviously not a factor of 24. Can we have 6? Yes, we can. 2 times 3 is 6. So it's just listing, you see. Can we have 7? No, it's a prime number. Can we have 8? Yes, we can. 2 times 2 times 2 is 8. And it's also the, oh yeah, it's 2 cubed, also 2 cubed, which is 8. Can we have 9? No, because we need another 3 to get a 9, which we don't have. Can we have 10? We cannot, because we don't have 5. Yeah, we need 2 times 5 to give us 10. Can we have 11? No, 11 is a prime number. Can we have 12? Yes, we can. 3 times 2 times 2 is 12. Can we have 13? No, 13 is prime number. Can we have 14? No, that requires 2 times 7. Can we have 15? No, that requires 3 times 5. Can we have 16? No, that requires 2 to the power of 4. We don't have another 2. Then the next one, so you repeat this procedure, you will find the last one is 24, which is itself. Yeah, any number is its own factor. So these are all the factors for 24. We just add them up because the question is asking for the sum of all the factors. And to do it quickly, we use some technique. So 8 plus, so number pairs. 8 plus 12, this is a good friends number pair. This gives us 20. 24 and 6 gives us 30. 1, 2, 3, 4. This is a special pair. If you see 1 plus 2 plus 3 plus 4, no need to think. Just shout out confidently. The sum is 10. So it's 10 plus 20 plus 30. The answer is 60. And then question B is finding the biggest prime number that is smaller than 50. The biggest number, okay, I'll write the factors of 24 over here. So it's 1, 2, 3, and then 4, 6, 8, 12, 24. Yeah. And then find the biggest prime number that is smaller than 50. So we start with 50 and we go in the opposite direction. Think about 49. Is 49 the prime number? No, it's not. It's 7 squared. So it's 7 times 7. Think about 48. Nope, even number. Will never be a prime number. Think about 47. That's it. That is the biggest prime number that is smaller than 50. Yeah, because it has no other factors apart from 1 in itself. There is a technique I can tell you for you to quickly identify if the number is prime number or not. That is, you look at the multiples of 6. And for example, 1 times 6 is 6, and then you plus or minus 1. Yeah, 6 plus 1 is 7. 6 minus 1 is 5. Both are prime numbers, but this doesn't always work. It's just a trick for you to identify faster. Yeah. For example, 47. Yeah, 6 times 8 is 48. And you see, it doesn't always work. 48 plus 1 is 49. This is not a prime number. But 48 minus 1 is 47. This is a prime number. Let's try another pair. 3 times 6 is 18. 18 plus 1 is 19. It is a prime number. 18 minus 1 is 17. It is a prime number. Okay. So just for your information. And then let's move on to question C. How many prime numbers are between 10 and 20? So because they are prime numbers, we don't need to consider the even numbers. Yeah, so that halves our workload. Just consider the odd numbers. So 11, 13, 15, 17, and 19. And pick out the ones that are not prime numbers, which is just 1, just the 15. It is 3 times 5. It has factors other than 1 and 15. So we have 1, 2, 3, 4, 4 of them. Also, oops, something's wrong. Something's wrong with the application. Let me see if I can restart it. Okay, give me a sec, everyone. I need to restart the application. It's stuck. Yeah, welcome back. Yeah, so coming back to the last one, although apparently my notes are all gone. Right, it's working again. So given that A, B, C are prime numbers, A plus B equals to 33, B plus C equals to 44, C plus D equals to 66, then what is D? D, we don't know if it's prime number or not. The answer for this one is 4. White. Yeah. So let's see. According from the first two equations, A plus B is 33, B plus C is 44, we can get so A plus B is 33. This is testing you if you're confident and proficient with manipulating these equations. This is equation 1, this is equation 2, and apparently we can do equation 2 minus equation 1. This is first content from the first lesson in the alternate term lesson. So 2 minus 1 gives us, on the right-hand side, we have 44 minus 33, so it's 11. And on the left-hand side, we have B plus C minus A plus B minus A minus B. And the plus B and the minus B, they cancels out. So what's left is just positive C minus A. So it's C minus A. So that gives us C minus A equals to 11 and C equals to A plus 11. Okay. And here, here's is the most important part of this question. It's the essence for you to quickly solve it. Because A plus 11 is a prime number, because C is a prime number, and all prime numbers are odd numbers. Yeah, so this is odd even analysis. Can A be an odd number? Yeah, odd number plus odd number. For example, if A is 3, 3 is a prime number, but 3 plus 11 is 14. And we know that all even numbers are not prime numbers. Yeah, they're composite numbers. So for C to be a prime number, A cannot be even. Yeah. Sorry, A cannot be odd. A must be even. I mean, C can be even. We know that there is one even prime number. That is the smallest one. That is 2. But we cannot have a positive number, a prime number, plus 11 equals to 2. That doesn't work. Yeah. But we can let A be 2. Yeah, A is the only even prime number, and it's still a prime number. So 2 plus 11 gives us 13, which is also a prime number. Okay, so that solves it. A is 2, C is 13, and because B plus 13 is 44, so B is 44 minus 13, 31. But that's irrelevant to this question. The question is asking for D. So C plus D is 66. D will be 66 minus 13, which is 53. Yeah, so might want to throw in some odd even analysis and also when you are dealing with prime numbers, yeah, because it's really handy, it's really convenient if you remember that all prime numbers are all odd numbers, but not all odd numbers are prime numbers. Okay. Right, so let's move on to question number 21. How many children would there need to be in the class so that at least 3 of the children were born in the same month? So this requires knowledge of a principle called the worst the worst situation principle. That means if you have found the worst situation, yeah, you just need to add 1 so that you can get the target, the guaranteed target number of situation. Okay, so first of all, the question we need to figure out is how many months are there in a year, and that will be 12. Okay, so that means let's consider the worst case scenario, the worst condition. That will be we have, for example, if we have 12 students and all of them are born in different months. Yeah, so we have none. We don't have the at least 3. We have none. None of them are born in the same month. Yeah, so January, February, March, and all the way to December. Okay, so 12. Yeah, 1 student in each slot. Okay, so that's 1. Yeah, we have at least. Okay, we don't have enough children for them to be born in the same month. Yeah, then let's give them let's have another round, shall we? So add another 12 students, also the worst case scenario. So another student born in January, another student born in February, another student born in March, and then all the way to December, another student born in December. So now we have two children born in the same month. The question is asking for 3, at least 3 children born in the same month. It says at least, yeah. So we just need to add 1, yeah. We can add this 1 child. Let's say Peter. Yeah, Peter, no matter which months he was born in, yeah, will fulfill the restriction, the condition that the question, the demand the question is asking us, at least 3. Yeah. So if Peter is born in January, then yeah, we have 3 children born in January. If he's born in February, then we have 3 children born in February. So the answer will be, as you can see, 12 times 2, because we have 2 layers, and then plus 1, yeah, 1 chosen child, which is 24 plus 1, 25. Okay, so this is the worst case scenario. Need for you to get the guaranteed, yeah, the guaranteed number of situations. You just need to fulfill, yeah, make the worst case scenario work, and then on that basis add 1. Okay, so if you're happy with that, we'll have a practice question with the worst case scenario principle. So how many children would there need to be in the class so that at least 2 of the children were born in the same month? Well, to be honest, I think most of you, if you understand the previous question, you can quickly get to the answer for this one. Yeah, I think this one should come first, and then the previous question should come later. Swap them. But anyway, let's have a look. So again, what is the worst case scenario? Let's ask ourselves this question. The worst case scenario is, so for the first layer, again, we have 12 children, and each of them are born in a different month. So from January all the way to December. So we have a layer. First children all the way to the 12th. And on that basis, we just need 1 more chosen child. 1 more. Okay, again, let's say Lewis, for example. Yep. Lewis, no matter which month he was born in, will fulfill this at least 2. Yeah, if he was born in January, then we can say there are 2 children born in January in the same months. Yeah, so problem solved. So the answer is a layer of 12 children plus the 1 chosen one, which is 13. Okay. Moving on to question number 24. Sharon had 80 tarts. 30% of them were pineapple tarts, 25% of them were egg tarts, and the rest were strawberry tarts. And the question A is how many pineapple tarts did Sharon have? We just multiply. This is just percentage. The total number is 80. And pineapple tarts, the percentage is 30%, so we just multiply. Okay. And I hope you're all confident with and proficient with the percentage multiplication. The percentage is equivalent to decimal 0.3. So it's 80 times 0.3, which is 24. So she had 24 pineapple tarts to begin with. And this is question A. And then for question B, we have how many more strawberry tarts than pineapple tarts did she have? There are 2 different methods. First method is you can find the actual number of strawberry tarts, which is all right. We need to find the percentage of strawberry tarts first. It will help if you know how to draw the pie chart. Okay, so 30%, 25% is just a quarter, and then 30% is about 1/3. So what's left is 100%, because that's the whole. The whole, the 80 tarts. Yeah, treat them as a whole, and that's 100%. Take away 30, take away 25. Okay. Yeah, so sorry, 30% should not be 1/3. 33.33333 non-recurring is 1/3. So 30% is something less than 1/3. Yeah, something like that. And 30 plus 25 is 55, and 100 minus 55 is 45%. So the rest, the strawberry tarts, is 45%. This is its percentage, its fraction. Then you can find the actual number by multiplying 80 with 45%, which should be 0.8, because it can be 80 divided by 100 times 45. Yeah, let's do 45 times 8, which is 5 times 8, 40. Carry a 4. 4 times 8, 32. 32 plus 4 is 36. So it's 36. 36 strawberry tarts. Okay, and then we find how many more strawberry tarts than pineapple tarts do we have? 36 minus 24, that gives us 12. Okay, this is the answer, and that's method 1. And then we can look for method 2. Clear some space over here. So here's method 2. You can look for the percentage, the difference in percentage directly, and then multiply that difference in the percentage with 80, and that will also give you the correct answer. So 80 is the whole, okay, multiply the percentage for strawberry tarts, which is 45%, and then minus the 30% of the pineapple tarts. So the difference in percentage, in fraction, is 15%. So 80 times 15 is 15% is 15 times 0.8, which should be 100, which should be 12 as well. I won't skip steps. I'll do it in full steps over here. So it's 80 times 15%, and that will give us 12. Also gives us the correct answer, and that's question B. And then moving on to question C. Sharon baked 20 more egg tarts. What percentage of her tarts were egg tarts in the end? So to do this question, we need to first find how many egg tarts are there to begin with. So C. Let's do 80 times 25%, which is equivalent to 80 times a quarter, which is equivalent to 80 divided by 4. So it's 20. We have 20 egg tarts at the beginning. Okay. And she baked 20 more egg tarts. The egg tarts will go both to the egg tarts and to the whole as well. Yeah. So for the fraction, it will be 20 plus 20. Yes. So we have 20 more egg tarts, but in total we have 20 more tarts as well. Yeah. No matter what type it is, we have 20 more tarts. So it's 80 plus 20. Yes. We're adding 20 to both the denominator and the numerator. That will be 40 over 100. And the new fraction, the new percentage will be 40%. And that's question number 24. And then moving on to the last question. Question, but also followed with a practice question for today. We have dividing a certain number by 3 leaves a remainder of 1. Dividing it by 5 leaves a remainder of 3. Dividing it by 7 leaves a remainder of 5. And for those who have done tons of calculations or division with remainder, if you're sensitive enough with numbers, you will find that, hey, there is a pattern between the remainder and the divisor for both for all 3 cases. Yeah, so we have 3, 1. Yeah, divided by 3 gives a remainder of 1. Divided by 5 gives a remainder of 3. Divided by 7 gives a remainder of 5. Yeah, so we're 2 less each time. Yeah, when we are dividing, if we have 2 more, say the number, for example, it's say 11. Yeah, oh, sorry, not 11, but 10. Yeah, 10, if we add 2 to 10, and that will be divisible by 3. And also, for example, for 5, if we have 8, yeah, and if we add 2 to 8, the 10 will be divisible by 5. Yeah, and actually, 8 divided by 5 is 1 with a remainder of 3. Yeah. So you see, we simply need to add 2 to the number. Yeah, then we can eliminate the 3 remainders. So the number, I'll just write the number, plus 2. And then it will be divisible by 3, 5, and 7 at the same time. And we all know that if a number is divisible by 3, 5, and 7 at the same time, then it must be divisible by 3 times 5 times 7. Yeah, makes sense? For example, if a number is both divisible by 2 and 3, then it must be divisible by 6 as well. Yeah. Say 36. Yeah, 36 is divisible by 6, and it is divisible by 3 and also divisible by 2. Okay. And it's the same case vice versa. So the number plus 2 is a multiple of what's 3 times 5 times 7. It's 3 times 35, and it's easy, 105. It's a multiple of 105. And also, we have a restriction from the question. The number is between 100 and 200. And we know that if we have 105 multiplied 2, that will exceed the 200 boundary. It's 210. So we cannot do 105 times 2. We can only do 105 times 1. Is 105. So it will be divisible by 3, 5, 7 at the same time. And we know 105 is the number plus 2. Okay, so the target number, the number we want, take away 2. We got that. It is 103. Oh, sorry, it should be 2 over here. Right, so let's have a look at the practice. So what is the smallest 3-digit number which leaves a remainder when dividing 5 and 11? Okay, so think about it, everyone. While you're thinking, I'll also read the second question as well. A number gives a remainder of 4 when divided by 7, and a remainder of 7 when divided by 10. Given that the number is between 300 and 400, what is the number? So this is almost, not saying 100% identical, but almost identical with the previous question. I'm sure you all know how to do it by now. Let's have a look at the first one first. So the smallest 3-digit number we want, okay, which leaves a remainder of 2 when dividing 5 and 11. So it leaves a remainder when divided by 5 and leaves a remainder when divided by 11. Okay, so if we take the remainder 2 away, the number will be divisible by both 5 and 11. Yeah, and we know that if it's both divisible by both 5 and 11, then it must be divisible by 5 times 11, 55. Okay, so the question can be rephrased to look at the multiples of 55 and which smallest 3-digit number, 3-digit multiple of 55 will be leaving a remainder of 2 when divided by it. Okay, and that is easy. It's just simply 55 times 2. This is the smallest 3-digit number we can get, which is 110. And we need a remainder of 2, so we simply add 2 to it. So 102 is the answer. Now moving on to the second. Hang on, Jaden, just let me finish this question. A number gives a remainder of 4 when divided by 7, and a remainder of 7 when divided by 10. So 4 with a remainder of, 7 with a remainder of 4. And 10 with a remainder of 7. So you see, we are 3 less than the divisor every time. So if we plus 3 to the number, then the number will be divisible by both 7 and 10. And it will definitely be divisible by 70, since it's 7 times 10. Okay, and we want to find a multiple of 70 between, that will be the number between 300 and 400. And that will be, let's say, 70 times 4 is 280, is less than 300. So no, so that will be 350, 70 times 5. Yeah, this is the number plus 3. Yeah, the new number will be divisible by 300, will be divisible by 70, but our actual number is actually less. Yeah, and we have to have the remainder, so take away 3, that will give us the answer. So 350 take away 3 is the final answer, 347. And that is it. That is the walkthrough session for today. It's a bit quick, so do you have any questions, everyone? I'll let you